Hi friends, welcome to follow up. Let's have a look at problem 34. Find the first and last position of element in sorted array. In this video, we're going to explain solutions based on binary search. So we either do a implementation from scratch or we use some well-known libraries. So here the problem statement is very simple. So given an array of integers sorted in non-decreasing order, we want to find the starting and ending position of a given target value. If target is not found in the array, so we're going to return -1, -1. So here the requirement is that we need to write an algorithm with logarithm runtime complexity. So here we have 3 examples. In example 3, so the list is empty, the target is 0, so the output is -1, -1. And similarly in example 2, we want to find 6. However, 6 does not exist in this list, so we are going to return -1, -1. The first example is the generic case. So in this example, the first appearance or occurrence of it is at index 3, and the last one is at index 4. So we are going to return 3 and 4. So here the constraints are the following. First, the length can be as long as 10 to the power 5, and also the list can be empty, and the numbers can be positive, can be negative, or 0. So nums is in sorted order in a non-decreasing fashion. So that's the target range, right? So with that said, we are ready to do the analysis. So here we would like to explain binary search. So actually this problem itself is now a very classic problem, and also it's very important to really digest the idea behind binary search. So in general, for binary search, there are 2 steps. First is how to produce order. So we need sometimes define Boolean functions to produce this monotonicity, or sometimes like check membership in a sorted list, the order is natural, right? The second one is search rank shrinkage. So in this video, we are going to focusing on this second part, how to do search range shrinkage. So here we want to comment that if one could grasp the thoughts in this video, so you should be able to solve quite a lot of problems related to binary search, especially problems in leleetcode. So here our plan is the following. So first we are going to solve this problem from scratch. In other words, we want to implement the 2 hyperfunctions to do the task. In other words, find the first occurrence and the last occurrence. And then we are going to use some well-known library to achieve this task. So the implementation from scratch is meant to demonstrate to you how to do the search range shrinkage. So with that said, let's move forward. So let's do the first one. So I want to implementation from scratch. So for this one, I'm going to write 2 functions. So the first function is going to a function that fetches the first occurrence. In other words, leftmost index if target in array or in the list. So here I'm going to define this function like let's see, define f. Let's just call it f. So we accept a list, and also we this target our goal, right? So here our goal is to find a mean index such that the nums at this index is greater than or equal to target, right? So that's our goal. So that's the role of this function, right? So for this one, I'm going to initialize the 2 pointers or 2 indices. So length nums -1. So this is the leftmost, this is the rightmost. So now we want to do the shrinkage. So here is a while loop. So here I'm writing L less than R, strictly less than R. So later we will hope that they will coincide, they may stop the while loop. So because we want to find the minimum index such that this condition or monotonicity holds, so we start from the left. So here I'm going to write mid to be something like this: R minus L, integer division by 2. So each time we move half from the left to the right, towards the right. So this is the the way we do shrinkage. And then we want to check if num mid is greater than or equal to go, right? And then we are going to do search range update. So we're going to, because we want to find the smallest one. So then in this case, we are going to set the upper bound to be the mid. So in other words, in this block, the index R always makes this true, right? So otherwise, so if nums mid is less than go, so it's too small, left side. So we are going to do left equals mid plus 1. Because in this else block, the mid does not make this true. So we need to write mid plus 1. So afterwards, so in this case, we're going to return R. Actually, because of the way we write the while loop condition, so L and R should coincide. However, a rule of thumb is that, if you look at this if block, so the mid, because we set R to be the mid, always makes this condition hold, so we can return R in this one. So this is the first function. So now let's look at the second function. So we want to write a function that fetches the rightmost index if target in list. So for this case, in this case, what we want to do, so here let's write another function. Let's call it G, right? So it's nums will go in parallel actually. So here what we want to do, we want to find the max index such that nums idx is greater than, is less than or equal to go. So that's our treatment for this one, right? So notice the direction. So due to the way we want to, due to the goal we want to achieve. So here let's again initialize the two pointers or two indices. Let's say length nums minus 1, and then well R is greater than L, right? So the shrinkage will be done like this. So we start from the right because we want to find the largest one, which is smaller, no larger than the goal. So here we shrinkage from right each time we move downwards by half, right? So now let's do a check. Num mid, if this one is less than or equal to go, right? So we can further make this larger maybe. So we are going to set L to be mid. So notice that because the way we set the left pointer, right? So this left always makes this condition hold, right? So the else block, if this condition is validated, so we want to shrink it, right? So we want to write R equals mid minus 1, right? So notice that you can compare with the first function. Here is mid plus 1, here is mid minus 1. So due to the way we write this while condition, so we hope that R and L will coincide if the target or goal is in the list. So what we want to return is, because this L always makes this condition true, we return L. So actually for this problem, if target inside, you can return R also. So now we finished the bulk of this task, or this first solution. So now let's prepare the return. So we have left, right. So this is F, so nums target, and G nums target. So here we need to check. So sometimes the target does not in the num. So here what we want to do is if not num, like in example 3, right? Or nums left, you can check 1, right? does not equal to target. So in this case, it means that the target does not lie in the list. So we are going to return -1, -1. So otherwise, so we're going to return left and right. So this actually finishes the first solution format. So before we make any comments, let's first do a test. Yeah, it passes one example. So this is the example 1, I guess. So now let's look at generic case. Yeah, it passes all the cases. So as for the time complexity, because of the half shrinkage, so these two functions f and g are logarithm runtime complexity. So it fulfills the requirement. So this is the first version. So actually, this version is very important. So though you can import some libraries to achieve the task, it's actually good practice, or it's sometimes required that we can implement from scratch. So here there are several points to be clear. First is that the while condition, right? You can see if you write some binary search, the conditions can be less strictly equality, or less than or equal to, or greater than or equal to. This is one thing. Another thing is that the way we do the shrinkage. So in the first function, we move upwards, and in the second function, we move downwards. So this is the second point. The third point is that what should we return? So in this problem, due to the way we write the condition, we return R and L, or L and R, both will work. So this is the one solution which focuses on the shrinkage. So in general, if we want to use binary search, it's also important to pay attention to how to define the monotonic function or Boolean function to produce monotonicity or order. So we have a playlist on binary search, so you are welcome to check out. So with that said, let's look at the second solution, which is shorter, but it's also playing the same role for solving this problem. So I'm going to change this one to be version v1. So now in the second version, we're going to use the bisect module. For this one, first I'm going to get the length of this nums. This is just for convenience. Then I want to find the left index. So here I'm going to use bisect left nums and target. So let me explain what this function or method do. So here we want to search insertion point for this target. So here the result, let's assume, is L. Basically it says that for the list nums left to this index L, all the numbers are strictly less than target. So this is one, right? So here, once we have this L, so we can do some check. Right? First, if L equals n, right, it means that all the numbers in nums is strictly less than this target. So in this case, we can directly return -1, -1. It basically means that the target does not lie in this list. So this is the one case. Else if, so here nums L does not equal to target. So in this case, we also know the target does not in this list, so we can return -1, 2 also. So otherwise, we know this L will inside this function. This target is inside this list. So now we want to find the right occurrence, so rightmost. So here let's use R because bisect. So here I'm going to use bisect right. So here is nums and target. So what does this function do? So the bisect right will have an index R. So it means that left to this index R, all the elements in nums is less than or equal to target, right? So if the target is inside the list, then the corresponding index will be R-1, right? So because we are in this else block, right, it tells that the target is in the list. So we just need to return the correct index. The first one is L, the right one is R minus 1. It's important to notice that this is R minus 1. So with that said, let's make a test. Yeah, it passes one example. So now let's look at the generic case. Yeah, it passes all the cases. So now we finished explaining the two formats of solutions to this problem based on binary search. So in the first one, we did implementation from scratch, meaning aiming to show or demonstrate how to do shrinkage, search range shrinkage. In the second one, we resort to the bisect module. Then we directly call the bisect left and the bisect right function to achieve the task. So with that said, I guess that's about it for this daily challenge problem. Thank you.